Okay, so my name is William. Okay, today's video is called, and I want to show you, it's called, what's the Bible say about galaxies? Now I'm going to be thinking, right? Why I'm talking about, I'm thinking about talking about this because the word galaxy is not found in the Bible, right? Well, right, but they're real, right? That's why I'm talking about them. Now, right, the word galaxy is not found in the Bible. But, they're real, right? That's why I'm talking about them. But I want to talk about galaxies and prove to you they can't last for billions of years. Okay? Because that's what atheists believe. But now, before we can talk about that, let's get into, the galaxies are called in different languages first. Before I can prove to you they can't last for billions of years. Where galaxy in Spanish is galaxia.
Galaxia.
Galaxia. Okay, so the word galaxy is galaxia. And here it is in French.
Galaxie.
Galaxy. It's how to say galaxy in French. You see, it's just still, yeah, it's just the same way. Once when we get to Mandarin, it will sound different. You only got, 3 words over here. Okay. So here's the word galaxy in Mandarin. Okay.
星系.
Okay, so Xingxi. There's also this word here. That's why I say galaxy in Mandarin. But now, I think this means Milky Way. Yeah, this means Milky Way galaxy. I'll have to put Milky Way in here. So Xingxi means galaxy in Mandarin. But, yeah, I think close that. Yeah, I also got this word by accident, but I think this is how to say Milky Way in Mandarin.
银河系.
Yeah, 银河系 is how to say Milky Way in Mandarin. So. Okay. Now, what about, I'm going to do Arabic next. Type the word galaxy. You got Amajara. Sorry.
المجرة.
Majority, yeah, that's how to say galaxy in Arabic. Now here it is,
Ginga.
oh yeah, so Ginga is how to say, yeah, okay. Yeah, I guess Ginga is how to say Milky Way in Japanese. You also got this word here. No, yeah. Sinky is another way to say galaxy. And so it's Sinky is how to say galaxy in Japanese, and Ginga is Milky Way. It's Milky Way in Japanese. So that's the difference. Okay. Now, what about Korean?
성운.
I need to type it right. Okay.
은하.
Ina. Okay, so Ina. Okay, Inha. It's how to say galaxy in Korean. Okay. Now we can do Milky Way next. Because I don't have that yet. Okay. I have to. Okay. Copy this so I can paste it here. No, I did not want to wrap text. Okay. Yeah, it wanted me to wrap text. Again, it wants me to wrap text. I said no. Okay.
Vía Láctea.
Via Láctea, it's how to say Milky Way in Spanish. No. Didn't want to delete the word nebula. Okay. Here's in French.
Voie lactée.
Well, like deep. Yeah, but I don't know why it did not. Oh. Oh, I know. It wrapped text again. There. Did not want to do that. And we got it in Mandarin, so.
银河系.
Yeah, hang on, she. Yeah, so. Yeah, let's just do it in Arabic now.
ضرب التبانة.
So I'll say, yeah, Milky Way in Arabic. So. And then, oh. We got Psyche. But, here. Let me get the word, let me get it in Japanese. Oh. There it is. Let's see what Google Translate is saying too. Okay. And I want to see how this translates, and okay, it's not translating right. Okay, no, close that. Then we got Ginga, and then you got this word. Milky Way. Okay.
Tennokawa.
And Mokowa. Okay, it's another. So that's another way how to see Milky Way galaxy in Japanese. Okay. And I want to type it for Korean. Okay. Okay, now let's close Google Translate because I only want to do this and now I'm going to do Milky Way in other languages too. So okay.
은하수,
Inasu. Okay, so Inasu, I'll say Milky Way in Korean. Okay. So I guess I did Milky Way as well. Okay, so that's but yeah, so Milky Way is the name of our galaxy. If I want to, so that's a picture of our Milky Way galaxy. And I know all galaxies, well, most galaxies are moving away from us, except for this galaxy, which is the Andromeda Galaxy. Yeah, so the Andromeda Galaxy is the only galaxy that's coming toward us. Even though atheists believe, the evolutionists, they believe it will take about 3 billion years for for the Andromeda Galaxy to collide with ours. But I'm not even sure why, but I'm not sure how they know that, first of all. Since I don't believe galaxies can last for billions of years anyway. And they said once they collide, they're gonna call it Milkdromeda, but but they can't even last for billions of years anyway. So I don't know what they're. So I don't know what they're saying. I don't know why they're saying that anyway. So here's a picture of another galaxy, the Spiral Galaxy. This is the Roll Pole Galaxy. I think the reason why it's called a roll pole galaxy is because it's at the Spiral Galaxy that kind of looks like a roll pole. And I'm gonna show you another galaxy, but it's there it is. One more galaxy. This one here. This is the Sombrero Galaxy. It's a galaxy. It's a spiral galaxy that kind of looks like a sombrero. Okay, so I'll show you all the galaxies now. Now I'll show you that there are different types of galaxies. The barred spiral galaxy, the irregular galaxy, and you got the spiral galaxies. And then you got the pericular galaxies, the elliptical galaxies, and then the lenticular galaxies. So those are the different types of galaxies we have in our universe. There might be. I'm not sure there's any more types of galaxies. These are the six. These are the six. But I don't believe that galaxies can last for billions of years. Now, why do I believe that? Well, because I believe they will probably Well, because first of all, they're rotating, you know, and I don't think they can rotate, forever. Here, I'll show you which way the Milky Way galaxy rotates. You see, the stars in our galaxy will be moving in a clockwise fashion, but if you view it from the other side, it will be if you had the mirror image of the galaxy, so the motion would be counterclockwise. So yeah, clockwise, and then mirror image, and then if you view it the other side, it will be counterclockwise. But you see, we have galaxies rotating in the other direction as well, which is backwards, which will be, counterclockwise, as we see, and then the other side will be clockwise. So not all galaxies that we see rotate the same way. Okay. I don't think galaxies can rotate for billions of years. And I'll tell you why right now, okay? So galaxies, unexplained spirals. Okay, so since they were first discovered, galaxies gave a source of wonder. Many are arranged into beautiful spirals, but if they have been spinning for billions of years, won't their arms lose their cylinder shape? That's what I'm thinking. I think if these are billions of years old, I believe their arms will lose their cylinder shape. That's what I believe. These spirals should lose their shape in a very old universe. Indeed, for instance, as a spiral arm suggests that the universe is very young. Large islands of stars, called galaxies, fold an inky blackness of space. The number of observable galaxies estimated at 170 billion. Each with billions or trillions of individual stars, such as numbers as Felix spins, so we cannot even begin to fart them. And we behold these shimmering wonders, and we naturally ask ourselves, where do all these gems come from? The first chapter of the Genesis brings a good answer. On day 4, the Creator made the stars also, Genesis 1 verse 16. The astronomers reject God's revealed history, however, they are still struggling to find an alternative explanation. One of our biggest challenges is living spiral arms that grace so many galaxies. Simply put, the spirals should lose their shape in a very old universe. Indeed, for instance, a spiral arm suggests that the universe is very young. Design of galaxies. Any reverse account galactic origins has a lot of explaining to do. Galaxies tend to be far apart and don't appear to have much matter between them. For instance, of our own galaxy, the Milky Way, is separated from our closest galaxy by any notable size, the Andromeda Galaxy, NR1, but by about 2 million light years of black space. Yet every galaxy is well stocked with stars. The Milky Way, M31, which are pretty ordinary galaxies, that are filled with about 200 million apiece, stretching about 100,000 light years from end to end. Ingeniously, other smaller galaxies orbit larger galaxies such as ours and M31. Galaxies come in two main types, spiral and elliptical. Elliptical galaxies appear, as the name implies, in elliptical shapes. Spiral galaxies, on the other hand, have a dense concentration of stars. The centers, called the nucleus, and graceful arms spiral outward from the nucleus, giving spiral galaxies a pinwheel appearance. Where did this order and diversity come from? The spirals generate the most common among astronomers. Beginning in the 1930s, astronomers have begun to debate the structural origin of spiral arms, and debate that continues today. Now, discovering a young universe. Before we look at the technical differences, we must counter the common misconception. Many people believe that stars are plentiful with spiral arms, but nearly absent between them. In reality, the densities of stars is the same between the arms within. If so, then do the spiral arms look so bright? The reason the spiral arms contain very hot bright blue stars is the light of these tends to dominate much as the visible spectrum, so the spiral arms stand out in photographs. It's particularly true of the black and white photographs, which were very blue sensitive, and more recent red and infrared photographs. The spiral arms much less pronounced because the more numerous red stars dominate the light. In addition to very bright blue stars, a lot of dust and gas present the spiral arms. Some of the dust and gas concentrate into clouds called nebula. Astronomers called the nebula blue stars, spiral tracers, because trace out the locations of the spiral arms. In the 1930s, astronomers realized a problem though. The outer stars needed more time to complete their orbit in the inner stars. In the instance of the center of galaxy increases, the stars ought to become unstable. That is, after a few rotations, spiral arms ought to smear out. Astronomers debated for a few years whether the spiral arms wound up or unwound, depending upon the direction of rotation. No matter which view are adopted, however, if galaxies are at least 10 billion years old, as generally thought, then no spiral arms should be left. Failed solutions. By early 1960s, astronomers they had the answer, but they had devised density wave theory. According to this concept, the spiral arms act like sound waves in space between stars and inter medium, ICM, and if a outside force compresses in stellar medium, clouds and gas and dust would arise in spiral arms. In addition to compressions of gas, would possibly form stars. According to this view, some new stars, which have massive blue stars, have very short lifetimes, only a few million years at most, not billions of years. The stars are critical thinking this idea work but they supposedly don't last long, and there isn't time for a wave to move along and leave behind the bright blue stars. So their theory proposed that the gravity in galaxies step to complete across the process collecting of material into stars. The details of spiral density wave theory have proven difficult to work out, but this viewpoint still has its diehard followers. By the 1990s, astronomers looked at the small satellite galaxies as like a mechanism to maintain the spiral arms, and none of this has proven very difficult to work to. Now, dark matter. The last decade, astronomers discovered much evidence for dark matter. Let's get compasses in the picture. Dark matter is very interesting and it gives off no light. But it's the total mass and exceeding the mass of light and matter. Its gravity likely is single greatest influence of structure its galaxies as well as the entire cosmos. Edenstein says that dark matter has confirmed the outer regions of the galaxies, but most astronomers currently think that this dark matter may allow the galaxies' spirals to survive. However, the event evidence for dark matter is higher than experimental rotation of portions of galaxies. May actually make the winding problem worse. not better. Creationists have long have argued that spiral arms should not exist in a very old universe, and that persistence of spiral arms suggests that the universe is very young. However, because of most evolutionary astronomers began with this assumption that the universe is billions of years old, and they are convinced that some mechanism will continue to uphold the spiral arms. If there are really satisfactory answer, they wouldn't continually such a new solution. Near failures that the creationist arguments should not be easily dismissed. Another wrinkle developed in recent years. Astronomers have photographed distant galaxies about 12 billion light years away, assuming, for the sake of the argument, a Big Bang happened 13.7 billion years ago. These galaxies are among the youngest in the universe. They have been diverse something nearby, presumably older appearing galaxies, if otherwise identical. In other words, although evolution has occurred. In some creation, we might have and expect that galaxies appear in similar nearby ones, but not with the evolutionary model. Once again, God's word sheds unwavering light and origin makes up in His grand universe. Here's Argo Blue Stars, next Argo fossils. Okay, and here's Answers magazine. The Institute of Answers points out at the heavens. Okay, explore evidence that the universe is young, from blue stars to spiral galaxies. Get up to date and search our extraterrestrial life. And we first read Dr. Jason Lyle's new model, explaining the distance distant starlight. You also don't want to miss articles from living fossils, in other words, your own planet, and point to the recent creation and global flood. So yes, these are why galaxies can't last for billions of years, including spiral galaxies, because they will lose their spiral shape, and they will lose their spiral arms. That's what I believe. They will lose their spiral arms and lose their cylinder shape. So no, they can't. So no, galaxies can't last for billions of years. Now let's learn more. Let's learn more about that too, because young galaxies are too old for the Big Bang. New galaxies for explanations. Term astronomers at the University of Texas announced that the starting discovery this year, 2004, they had used for mentoring a Belecco telescope in Chile to find long string of fully formed galaxies. And it has sometimes been called Frances filament, after the team member Dr. Paul Frances from the Australian National University. Astronomers calculated that the supercluster was 200 million light years across and right in the distance at the edge of the universe, 10.8 billion light years away, and a light year is how far light would travel at a current speed. 300,000 kilometers, and using maps of year, regions of kilometers, and 5.8 trillion miles. However, this is a huge problem for evolutionary timescales. These galaxies will exist according to the Big Bang cosmology. They shouldn't have the time to form. The astronomers have used to block or light from other sources. This is able to block out galaxies far from Earth. They expected to find young, faint proto-galaxies that spread evenly throughout the area. Instead, they found 37 mature bright galaxies that seem to be right up to a string and emptiness elsewhere. It was exactly the opposite of what they expected from the Big Bang theory, of observations of sliding springs. Observatory in Australia confirmed that this galaxy cluster was real. The galaxy cluster lies in the direction of the southern hemisphere constellation the crane. At such a distance, evolutionary astronomers assume that they are viewing the galaxies as they were around 11 billion years ago. This actually suggests that 2 billion years after the Big Bang supposedly formed the universe. Okay, the research team calls a stir. They reported the discovery meeting of the American Astronomical Society on the 7th of January of this year. Astronomers around the world were astonished to how mature galaxies could have formed so fast in a young universe. In a current main evolutionary model, galaxies form variations in the density of matter produced by the Big Bang. Big Bangers imaged that the universe needed billions of years before the stars and galaxies could form into inexplicable structures and we see near the Milky Way galaxy today. This is a new discovery, precisely a reverse Big Bang predictions. Galaxies need to be formed mature structures. The galaxies are aligned in a long string. The galaxies are also more than 300 million light years long. Okay. Dr. Frinsett himself expressed the problem, but the situations tell us they cannot take matter to an early universe and line up as strings, he said. It has been a long time since the Big Bang to form structures in this colossal. This was a cosmologist doubting that find a way to find this evidence into the atheistic Big Bang model. However, this would really show that the scientists were always interpreting facts in the light of theory. Theory, in turn, is one belief system. The Big Bang theory is based on naturalism, a belief system that discounts God's recent supernatural acts to create the universe. The existence of such large, mature galaxies lined up in the beautiful element makes this a more sense that pretend within the biblical belief system that is God rapidly and supernaturally created fully formed stars and galaxies on day 4 of creation week by the word of our Lord were the heavens made. And that's in Psalm chapter 33 verse 6. Now, there's another article I want to show you, okay? So smaller galaxies too many for the Big Bang. Dark matter will cause galaxy collisions, meaning galaxies like our own Sugar Galaxy extremely rare. It's extremely study of the university born shows the standard of Big Bang model does not predict us observed number of late type galaxies, galaxy collision box like our own. The galaxy we live in, the Milky Way, is a late-type galaxy, as are most galaxies in our local universe. These galaxies are rotation-dominated, star motion particularly circular, opposed to early-type galaxies, whose mission of dominated star motion is random. Late-type galaxies run in disk and see figure 1. So additional sky survey shows about 80% of our local universe galaxies in a spiral and attenuate structure, i.e. late type. The University of Bonn researchers find that the latest Big Bang supercomputer simulations have produced a very few late type galaxies. Okay, this is because the simulations show that galaxies lose a lot of angular momentum, so that would be the momentum. Simulations are able to produce bulgeless disk galaxies, yet many are observed, and this has been identified in one of the studies since the 1990s and is known as the angular momentum problem. The problem with major problem and its galaxy collisions in the standard model. Every galaxy is surrounded by halo, see figure 1, because it has been starred. This for stars is dark matter, although dark matter is invisible and electromagnetic radiation. Supposedly interacts chemically with matter in itself, and because galaxies are 90% dark matter, genetically helium exerts a strong gravitational pull on nearby galaxies. It's a thought that large galaxies can absorb smaller ones without affecting structure, and larger galaxies, but emerging galaxies of a similar size like the Milky Way and Andromeda. The sun and stellar disk of synchronicity thicken, bolts committing and grow and bigger one. And I'm to the point that where the galaxy considered the elliptical galaxy rather than spiral, but this because the collision reduced the angular momentum needed to keep the disk shape. Modern cosmology estimation suggests that mergers, very common 95% of the galaxies who have undergone mergers in the last 10 billion years, and 69% of galaxies superhellium mass have won a major major in the Big Bang's history. So therefore, difficult to explain large number observed bolts this galaxy somehow meant to explain angular momentum. In our universe, about 50% of lane type spiral-length galaxies do not have big merger and built bulge, i.e., observe that bulge is too small to indicate that the galaxy has been the merger. The University of Bonn researchers found that the research of universe has been different than predicted with the Big Bang, that the chance of started model could produce the observed galaxies is minuscule, i.e. 2.9 times 10 to the 36th power. Effectively zero. Either the merger history is not correct, thereby the started model of cosmology is incorrect, as the researchers suggest the time is not sufficient for the mergers to occur. The biblical creationists would suggestly entertain both options, but the University of Bonn searchers are tied under a distinct worldview, and they suggest only that standard model as cosmology is incorrect. The prefer modified Newton dynamics bond theory is better explanation for the observations. Bond. Okay, or BOMD bond, yeah. First proposed in 1993, does away the need for dark matter and therefore the strong conditional action between dark matter halos, which produce a large number of galaxy mergers in the standard model. So Bond, or MOMD, has its own problems, and the ACDM standard model still has dominant cosmological model, mainstream science, while as secure scientists work at trying to improve these two models. There's a movement of biblical cosmology, recent via creation via explanation of the flat galaxy rotation curves, millions of the flat disk-shaped galaxies. In our studies, the simulations, remember, of the cosmology of a circle of science of James Gunn. University said that the intensive science of renewable explanations, and you can't do that in cosmology. So galaxy classification. So you can see right here at figure 1, are such a Milky Way showing up on the top side of units and disk bulge and halo. And you want to see figure 2 right here. One-ton disk ellipticals number 0.9 indicates that it's just the circle. E99 has high eccentricity. And for spiral barred spirals, another indicates as barred tiny wound arms. Or spell bulge, C has no bar. You'll see would a small central barge, or letter B in between. Upon it, a bar in a medium. Central bars are less than A, but more than C. The first 7 Galaxies program, you came up with the following categories. Add an early type. Spirals. Okay, bar spirals. 5 irregulars. Okay, and the turning focal figure 2 is generally thought to be evolutionary sequence, where galaxies evolve basic mythologies or more indicate, and the Degols were therefore termed early galaxies, and spiral regular galaxies were known as late-type galaxies, although this is no thought of galaxies to evolve. Galaxies to evolve, but they are right to left figure 2, associated with type that it's stuck. Well, do galaxies evolve? Well, my answer is no, first of all. And, God formed the galaxies on day 4 of his creation week. So, and we know that, and so yeah, galaxies can't last for billions of years because they will lose their spiral arms. And also lose their slender shape. Eventually. That's why. So the reason why we have galaxies is the reason why is because the Bible is true. So yes, galaxies prove that the Bible is true. And there's no other explanation about that, but yeah. So that's why. And they want to use dark matter to rescue their billions of years, but they're stupid anyway. Because they want to keep their billions of years, and instead go into the Bible. I was trying to get saved, so yeah. So the galaxies prove that the universe is only about thousands of years old, not billions. And anyway, I was trying to get saved according to the Bible. So point of evolution is a damn souls to hell. And also the point of the flat earth is a damn souls to hell as well. The only goal to heaven is to believe all Lord Jesus Christ. Salvation is by faith on the grace of Jesus Christ alone. And once you know you're saved by His means of truth, meaning that you can't lose your salvation by His means, and it's a salvation is easy. What you do is believe in Jesus Christ for salvation. And what I'll talk about next video is it's called "What is the Bible say about telling the truth?" Well, I'll talk about that next video. Because it'll go right now. So thank you for watching this video. Hope you enjoy us. Bye.